Changes in state. What happens when a solid is heated? The solid first warms up, and then it melts, and then it warms up, and then it boils. So we have phase changes taking place. So we can look at this heating curve, and let's say that we start at negative 20 degrees Celsius, and we're looking at water, H2O. So what we're going to notice is at first, our sample is a solid. And we're going to add energy into that solid, which is going to be represented as a temperature change. During this time, the random vibrations of the water molecules start to increase. As the temperature of the solid is increased, a point is eventually reached where the liquid and solid have identical vapor pressures. At this point, the substance is going to start to melt, or we're going to break away from the lattice and change to a liquid. Now, when we talk about this particular point on our graph, we're looking at a mixture of ice and water. And we refer to the enthalpy of fusion as the energy that has to be added in to break or disrupt the ice structure by breaking the hydrogen bonds. And this enthalpy change occurs when the substance melts from a solid to a liquid. Now we've got this term called normal melting point. And normal melting point is the temperature at which a solid and a liquid have the same vapor pressure under conditions where the total pressure is 1 atmosphere. Now we're going to notice that for water, as our substance is changing from a solid to a liquid, that occurs at 0 degrees Celsius at standard pressure. And the temperature is constant until all of the solid has changed to a liquid. Once that happens, the temperature of our liquid will start to increase again. And the kinetic energy of the particles in that sample is going to go up as our temperature goes up. Eventually, our water is going to reach 100 degrees Celsius. And at this point, the temperature is constant until all of the liquid changes to a gas. When we deal with boiling point is the temperature at which the vapor pressure of the liquid equals atmospheric pressure. And normal boiling point is the temperature at which the vapor pressure of the liquid equals exactly 1 atmosphere, or standard pressure. Now, once all of our liquid has changed to a gas, if energy continues to be added in, the temperature of the steam will go up as the kinetic energy of the gas particles goes up. Now, another type of diagram we can see is what's called a phase diagram. So here's an example of a phase diagram. We've got temperature along the x-axis and pressure in atmospheres along the y-axis. And we're looking at the states that change at given temperatures and pressures. And these particular graphs are for when our system is a closed system. Now let's think about this for a second. Let's say that we've got a substance and it's at a low temperature and a high pressure. Low temperature means that the particles don't have a lot of kinetic energy, so they're not moving around very much. High pressure means the particles are being forced closer together, so our substance would be in the solid state. If we've got a substance that's at a high temperature and a lower pressure, that means the particles in that sample are moving around a lot and there isn't anything forcing them together, so our substance would be a gas. And if we're in between those two states, our substance would be a liquid. Now, in this particular diagram, we've got 4 different experiments that are being explained. So let's start with experiment 1. And experiment 1 is at 1 atmosphere of pressure. And as we increase the temperature, what we're going to notice is originally our substance is in the solid state. Eventually we get to a temperature where the solid changes to a liquid, So that line represents our melting point. As we increase the temperature, our liquid increases the kinetic energy of its particles, and eventually we get to the temperature where our liquid changes to a gas. That line represents our boiling point of our substance. So at 1 atmosphere of pressure, we've got a solid changing to a liquid, changing to a gas for experiment 1. Let's say we move on and we look at experiment 2 on our graph. And in this case, we're at an extremely low pressure. Well, in this case, we start out with a solid, and as we increase the temperature, our substance goes from a solid directly to a gas. This process is called sublimation, when we skip the liquid state altogether. Now let's look at experiment number 3. If we start at a low enough temperature, our substance starts out as a solid. And as we increase the temperature, eventually we get to a point where all 3 states coexist at one time. This particular point is called our triple point. Above the triple point, if we continue to increase the temperature, our substance will be all gas. So in experiment 3, we start out with a solid. We get to our triple point where all 3 states exist at one point, and above that we have all gas. Now let's look at experiment 4. Experiment 4 is a little bit different. We're at a much higher pressure, and we have our substance starting out as a liquid because of the high pressures. Now we've got a couple of points that we need to define. One is called our critical temperature. And the critical temperature is defined as the temperature above which vapor cannot be liquefied no matter what pressure is applied. We've got what's called our critical pressure. Our critical pressure is the pressure required to produce liquefaction at our critical temperature. And the last thing we have is what's called our critical point. And that's our point on our graph all the way to the left. And the critical point is defined by the critical pressure and temperature of a particular substance. Beyond that point, our substance is in an intermediate fluid region.